All right, this is lesson 1.4. We're going to solve problems using linear systems. So our goal is to practice solving problems that can be translated into systems of linear equations. Okay? Linear systems are used to model all kinds of real-world problems. It sometimes takes some thought to translate the problem from English to mathematical symbols. But once you're done with that, it's pretty straightforward. Okay? So here's our first problem. Match the situation with one of the linear systems. So you have 9 packages of parchment paper. Some packages have 3 rolls, but some have only 1 roll. In all, there are 20 rolls. Okay? So we can start this off by saying, let's let X represent the packages with 1 roll. Yep. Where is the paper? Here it is. Switch to a pen. I think it'll be easier to see. Maybe not. So let X represent the packages with 1 roll, and we'll let Y represent the packages with 3 rolls. Okay? So now we have to decide of these 3 equations here, match the situation with one of the linear systems. Okay? So if we know that this is our situation, X represents the packages with 3 rolls and Y represents the packages with 3 rolls, X is with 1 roll, we know that X plus Y is equal to 9, because we know there's 9 packages total. Okay? We also know that there's 20 rolls total. So we know in each X package there's 1 roll, so we could write out 1X, plus in each Y package there's 3 rolls, so we're going to times the number of rolls times the Y packages by 3, and we know that gives us a total of 20 rolls. All right. So what's the answer here? Ready? A, B, or C? What's the answer? Assuming I've done everything correctly. B, right. Good. So the answer is B. It's given to you right there. Any questions with that first one? All right, next one. Match the situation with one of the linear systems. You have some $2 bills and some $5 bills. We don't have $2 bills anymore, but at some point in Canada, believe it or not, we did. In all, you have 7 bills worth $29. So we can say, let X represent number of $2 bills, and then we'll let Y represent the number of $5 bills. So we know we have a total of 7 bills. So RC, how can we write our first equation? We know we have X is representing the number of $2 bills and Y is representing the number of $5 bills. We know we have a total of 7 bills. So how could we write the first equation for this?
X
Yeah?
plus
Yep.
Y equals 7.
Beautiful. Yep. Exactly right. Next, we know we have 7 bills worth $29. So, Alan, how do you think we could write the second equation? If X is the $2 bills and Y is the $5 bills, how could we write it out?
2X
Yep.
plus 5Y.
Beautiful. Yep. Those look good to me. So then what's the correct equation, Max? A, B, or C? A, right. Is it hard to see? A. All right. All right. Mark has a total of 95 Pinnacle and Nike balls in his golf bag. Twice the number of Pinnacle minus the number of Nike balls is 1. How many of each ball does Mark have? Okay. So we know we have Pinnacle balls and Nike balls. So what could we use for our variables? Engineer.
P and M.
Yeah, P and N. Good. So let's write it out, right? So let's say let P. Tell me what would I write?
Let P be the amount
We would write represent.
number
Yeah, the number.
of Pinnacle ball.
Good. Of Pinnacle golf balls. Just keep it clean here. We'll continue to say golf balls. All right, and then we will let
Let N
yeah
represent the number of Nike balls.
Nike golf balls. Okay? All right. So he has a total of 95 Pinnacle and Nike golf balls. Twice the number of Pinnacle minus the number of Nike balls is 1. How many of each ball does he have? Okay? So the first part, we know the total of both of the balls is 95. So what could be the first equation? Teori.
For the second example,
Yep.
like 2x plus 5y equals 25. How come like A, it doesn't say 2x?
Oh, does it not? I might have messed that up. I was trusting Max here. I saw the second one. Oh, you're right. What would it be then in this case? We have any of these, right? Oh, I know why. I think they reversed X and Y here. X plus Y is equal to 7. 5x. Yeah. Yeah, they let Y in this case they let Y represent the number of two bills and X, I don't know why. But then that changes this from 2x to 2y plus 5x. So in actual reality, it's not A, it's B. Good catch. Ethan, what happened to you there? You didn't catch that one?
Sorry, I just tried.
Yeah? Come on, man. You gotta help me out. Make mistakes all the time. It's all good. Make sense? Are we okay with that now? You see why it doesn't matter for the first one, x plus y, because it doesn't matter the order, right? But they had different for the 5x and 2y. They're letting y represent the $2 bills, you can see here. So they just had it reversed. That's where I got confused, I guess, when I picked A. Why'd you pick A, Max? Any particular reason?
Well, I guess.
Oh, you just guessed? Okay. No worries. All right. So we got the letters P and N here. What can we write for our first equation? Andrew.
N plus P equals 95.
Okay, beautiful. I agree. Okay, now the second equation. It says twice the number of Pinnacle minus the number of Nike is 1. Engineer.
Would that be like N squared or
No, not N squared. Josiah. What do you think? Twice the number of Pinnacle, so twice our P variable, right? Minus the number of Nike balls, N, is 1. So what would I write, Josiah?
find out how much.
Say it louder.
Like, find out how much Pinnacle and Nike.
Yeah, we did that with the first one. We added them both up to get 95. But now we have this other condition here, Josiah. It says twice the number of pinnacle. So what would you write for twice the number of pinnacle balls, golf balls? What would you write? Right? Yeah, so 2 what? Yeah, 2p, yeah, so twice the number of pinnacle. And then it says minus the number of Nike balls. So what would I write? Yeah. Minus what? N, yeah, equals? Sorry? No, not 95. Yeah, equals 1, yeah. It's right there, it's telling us. Pretty straightforward. Now, how many of each ball does Mark have? Okay, so here's our 2 equations. Now, so we need to calculate, we need to find out what N is and what P is. Now, we've learned how to do this, right? By elimination. I'm gonna rewrite the bottom one, just switching the order. Actually, I probably should have rewrote the top one. Let's rewrite the top one. All right, Pinnacle plus Nike, because Pinnacle came first. I didn't change anything. I just reversed the P and the N. Okay, so here's our 2 equations. Now, we have some options here on how to solve this, right? From 1.3. Adrian, can you tell us what you would do? You could do that, yeah, and then you could get rid of the P's, right, by minusing. That's a harder way to do it. Yeah, what's up, sir?
Just so you know, they're gonna invite you soon. They're gonna
Okay.
send me a form, you just fill it, I'll let you know.
Okay. Lucas, tell us. Yeah, you get rid of the ends. And how do you get rid of them? When 2 variables have opposite signs, what do, Rudy? You add them or subtract them? When 2 variables, you want to get rid of them, they have opposite signs. You're going to add them together or subtract them? Yeah, add them. So we're going to add these 2 equations. So what's P plus 2P, Rudy? 3P, yeah. And what's N plus negative N, Rudy? No, N plus negative N. No, N plus negative N. So you're going N minus N. No.
0.
Yes, 0. Good, good. And 95 plus 1? 95 plus 1?
Oh, 96.
Okay, 96 divided by 3. 32, good. All right, how many pinnacle balls do we have, Janier?
32, sir.
Good, 32. So now what am I going to do with that, Janier?
32, and then you just... How much times is that going to 95?
No. I don't, what do I have to do? Yeah, why? Why am I plugging it back in?
Just to make sure that you're correct.
No. Andrew, why? Tell him why. Yeah, we'll do that at the end to see if we're correct, but we still don't know what N is, right? So we need to plug it back in. So if we plug it back in there, we actually get 32 plus N equals 95. Okay? So how many Nike balls are there? Golf balls? 63. Okay? Now you can plug back in because you have N. You can plug it back into either one. I can tell you I'll save some time. Tell you that we are correct. Okay? So the answer is, how many of each ball does Mark have? Now you have to write this out to get full marks. If you just left it like this, even with little nice boxes, you wouldn't get full marks because there is a mark. Usually, word problems are worth more. Yep.
Therefore.
Sorry?
Therefore.
Oh, yeah. Therefore, yeah.
Therefore, Mark has 63 Nike balls and 32 Pinnacle golf balls. No, sir,
Whoops, my bad. Okay? Any questions? Moving on. So far, they've been very easy. Let's see if they get a little harder now. All right. Question? No? Okay. We are going to solve a distance, speed, and time problem. Ooh, all right. Sarah travels 40 kilometers up a river in her motorboat in 4 hours, but takes only 2 hours to return downstream to the same place. Determine the current and boat speeds. Determine the current speed and the boat speed. It might be more clear. All right. Does anybody remember this triangle? I think it was from grade 10 math and science. Grade 9 science. Wait, I'll draw it a little bigger so you can see it.
Is that how you find density?
No. Distance, speed, and time. You guys remember this? Some people are nodding, some people don't remember. D. Okay, so what this triangle does is like a magic triangle. So it tells us that distance is going to be equal to this times this, right? So distance is equal to speed times time. Okay? It also tells us that speed is equal to distance over time. Distance over time. And it tells us that time is equal to distance over speed. That makes sense? You guys see how that triangle does all that? Any questions on how the distance speed triangle works? Okay, so we're asked to find determine the current speed. I'm going to put it in there because it's a little clearer. Current speed and boat speed. So those are the things we want to find. So usually the way you set your variables, I shouldn't say usually, always, the way you decide what variables you're choosing is based on what it's asking you to find. Okay, so sometimes it's the hardest part, it's just starting it. Jaden, can you tell us what variables you would choose here? Like we have to write out let something represent something. What would you choose? Anyone else can help? Jaden? Nobody knows. Okay, so determine the current speed and the boat speed. So it's telling us what to determine. So you can just write out what you need to know, right? So we need to know let something represent the current speed. Why am I writing that? Because we want to know what the current speed is. It says determine that. And then I also have to say let something represent the boat speed. Okay, now, Jaden, can you pick a variable? What would you say for current speed? C, yeah. And what would you say for boat speed? B, yeah. Okay, does that make sense? Does everyone understand how to choose the variables, how to start the question? You can't get that far, you can't do the question, right? Yeah.
We write let when it's to solve for like what we need to find.
Do what?
Oh, never mind, I get it.
Okay.
Wait, do you have to write let, or can you just put like a let?
No, you have to write let. Let this variable represent. You have to write let. You have to write represent. That's all communication marks. Any other questions? All right, now I'm gonna draw like a little river here. All right. And we got a little guy here. He's in a motorboat. That's as good as I get at art, okay? And when this is the current of the river, so it's like it's moving this way. Okay? And we decided to represent this the current speed as a c, so I'm going to put a c there. And then we have our little guy here, and he's traveling at b, right? His speed is at b. Okay? Right? And this is called downstream, because he's going with the current. Does that make sense? Right? Now, if he's going against the current, so I'll draw him again. So his speed is still going to be b, but now the current is actually running this way. And this would be called upstream. Right? Because you have to subtract the current that's running against him or her. Okay? Let's make this a her. Okay? She's traveling upstream, he's going downstream. Any questions about that drawing? Now, how did I come up with that drawing? How did I figure that out? Yeah.
With the context.
Sorry?
With the context.
With the yeah, the context of the question. Yeah, I read the question. I thought about it. Sarah travels 40 kilometers up a river in her motorboat in 4 hours, but takes only 2 hours to return downstream. Okay, so I have to think about it. What is upstream? What is downstream? So actually, I probably should have drew this one first because, you know, that's what she did first, and then she went back downstream. Okay, so she's actually going like this and then coming back downstream. Oh yeah, it is Sarah. So when she travels this way, she's going downstream. Right? That's downstream. If your current's running this way, and that's upstream. Hopefully I'm not confusing you guys with my very bad drawings. Does this make sense? Let's get rid of this one. Okay, it's only one person, Sarah. Should have paid closer attention to that. This is when she goes upstream with the current, with B, and this is when she goes downstream. Any questions there? Okay, so I'm glad you're still with me. All right, now it says Sarah travels 40 kilometers up a river in her motorboat in 4 hours, but takes only 2 hours to return. So we know that distance from our magic triangle, our distance measurement is our speed times our time. Okay, because of this triangle. You have to know that triangle. Okay, our distance is our speed times our time. Okay, so our distance that she travels when she goes up a river is going to be is our time, which is 4, times our speed. And with our speed when she's going up the river would be represented by what? This is the hard part here. I think I'm going to rewrite this. Okay, distance is equal to speed times time. We know our distance is 40 because it tells us how far she travels, 40. And we know that's going to be equal to her speed times her time. Now we know when she goes up travel, in 4 hours, it takes her 4 hours when she goes upstream. So I'm going to put my 4 hours over here. Now I need to determine her speed when she goes upstream. So what would that be? Jaden? Yeah, but we know the speed, right? We know the speed from this B and C. That's what we want to do. We want to get these variables into the equation. You're not wrong, you're right when you rearrange this. But if we spend all the time with D and S and T, we're not going to solve for the variables that we need, C and B. So what is the speed in association with the variables that we've now defined as her boat speed, right? And her current speed. What can I say is her speed when she travels upstream? It's taking her 4 hours. What can we say? No kids. C minus B. Close. But incorrect. Yeah. B minus C. Yes, that's what I like. Yeah. And the reason it's B minus C and not C minus B is because her direction is the boat speed. Right? You understand? And you're minusing the speed of the water. The water is going against the boat. Does that make sense? All right, so we got one equation. Now we have to do another equation. We're going to do the second equation. This time she's going downstream. Okay, she's going this way. Okay, the distance she's going to travel is going to be the same, right? She's traveling the same 40 kilometers. But we know that it takes her how long? Douglas?
2 hours.
2 hours. So we know this is going to be a 2. Now we just have to calculate the speed again. What would the speed be when she's going downstream? Jafet?
C plus B.
Yeah, C plus B or B plus C, right? Very good. Right? She's going downstream, so she gets help from the stream. Does that make sense?
Sir,
Yep.
What do you add?
Sorry?
What do you add then?
How do I add?
Like, why do you add?
Because when you're going downstream, you add the speed of the water plus the speed of the boat. They work together. Right? Make sense? So we finally have two equations here. Okay? They're not in the nicest format, not too familiar with, but so we're going to have to do some math here. We're going to have to expand these equations and rewrite them. Ethan?
So you're minusing, when you're minusing, it's the boat speed minus the current speed?
Yeah. Yep. Because the current is fighting against the boat. All right, so let's do some quick math here. We're going to divide both of these equations by 4, right? Because we're going to get rid of the 4 on one side. It goes into the 40 on the other. Okay, so what we end up with is 10 equals B minus C. And then on this side, we're going to divide both sides by 2. So this 2 goes away. So we get 40 divided by 20. We get 20 equals B plus C. Any questions? You're good? Josiah? All right, Josiah, good. What are you going to do next now? Make it easy for us. Yeah, you add it. Why do you add it? Because what? Nope. You would have been right here if you added or subtracted, actually. But if you're adding, why are you adding? You got to pay attention to what's going on here. What are we trying to do here with the two variables? What are we trying to do here? Why are we adding or subtracting? What are we doing? Yeah, you're trying to find the answer, but you want to get rid of one of these variables, right? So if we add, what variable do we get rid of, Josiah? Yeah, the C, the minus C and the plus C are going to become 0. So what is the B? What's B plus B? Not B2, but 2B, right? So then B is what? Yeah, 30 divided by 2? 15, yeah. Then I'm going to take my B value, I'm going to sub it back in here. So then I would get, I'm going to go up, let's go down here. 10 equals 15 minus C. So we get minus 5 equals minus C. C equals 5. All right? So B is 15 and C is 5. Now, with any word problem, we're not done, unfortunately. There's 2 more marks up for grabs here. Believe it or not. You guys have done so much work here. You only got 3 out of 5 so far. 2 more marks here.
You gotta explain it.
You gotta explain it. You gotta kind of, there's 2 things you gotta do. You gotta worry about the units, kilometers and hours, and you have to explain it. Who wants to try to do that? Yeah, RC.
Isn't she like going in when she's going upstream? Isn't she going like 40 kilometers an hour? 40 kilometers an hour?
Nope.
Oh,
When she's going upstream,
Yeah.
no, she's going,
10 kilometers an hour.
no, so I think you're getting confused. We've already won here. We've done it, right? We found the boat speed. It says determine the current speed and the boat speed. We have them. The current speed is this and the boat speed is this, okay? So we don't have any more real math to do. We just got to explain what we got. Ethan.
therefore, Sarah is moving at 15 kilometers per hour downstream.
No, you don't need any of that. You just need the current speed and the boat speed. Yeah, Adrian?
Therefore, the boat speed is 15 and the current speed is 55 kilometers.
The boat speed is 15, yeah, and?
The boat speed is 5.
and the current, no, I think you had it backwards. And the current speed is 5. That's all I'm looking for. I was just looking for a conclusion statement. Now there's only one reason why you wouldn't have got full marks here. Because a speed of 15 doesn't mean anything. Yeah.
You have to add the kilometer unit.
Yeah, so what would it be?
15 kilometers per hour.
Yes. Okay, understand? You got to go back to the question. Try to really think about what it was asking you. So that's full marks. It's going to get harder, unfortunately. Example 3. Ooh, another water one. A canoeist took 2 hours to travel 12 kilometers downriver.
Hello.
Hi there.
Hi, is Ethan in class?
Yep,
Can you come to the office for a quick moment?
sure.
Thank you.
Okay, so we have to deal with this equation again. Distance is equal to speed times time. So you need to remember this triangle. The really thing you just have to remember is that distance is on top, because you could put S and T in opposite order. It won't matter. Distance is on top. That's it. Okay. All right, so what does it ask us for? It says, find the speed of the boat in still water and the speed of the current. So who wants to write the setup sentences? Remember, this should be the easy part. Just reiterating what it wants us to find out. So Liam, try. What are we going to write? I have to write let something represent something. What am I going to write? Let S represent the what? Okay, sure, the boat speed. All right, and what else? Yep. I'm just going to change this S. Oh, sorry. What could we use instead of S again for boat speed? Yeah, let's use B again. I think that makes more sense because they're both speeds. All right, so we got our sentence. You know, you're going to get a mark for that for sure. That's an easy part. Okay, now we got to do some work here. It says the canoeist took 2 hours to travel 12 kilometers down a river. So we're going down the river this time. So it's very similar to the last question, right? We know we're doing distance is equal to speed times time. We know the distance here happens to be how many kilometers? 12. Is equal. We know the time. How long did it take when they went downriver? So we know the time is 2. So we just have to get the speed again. We know speed is represented by distance